So on the next question, we're going to be doing a diagram made of two equilateral triangles. Equilateral triangles means that every angle is the same. They're all 60 degrees, okay? So essentially, when you go up here, you can see the equilateral triangle, this one, and this one. That means that's 60 degrees, 60 degrees, 60 degrees. Vice versa, this has to be 60 degrees, 60 degrees, and 60 degrees. Okay. And it's also made up of two parallelograms if we're observant enough to see this. So the parallelograms will have to be, this is a straight angle, so the parallelograms will be 120 here. Now parallelograms, when they turn a corner, this is what's called two interior angles. If the first angle is 120, the second angle has to be 60 because you have to turn a whole 180. Or in a different parallelogram, it could be 100 degrees on the bottom. That'd make it 80 degrees on top for it to be a parallelogram. So that'd be that'd be 60. That makes this one also 60 because in a parallelogram, opposite angles are the same value. So this has to be the same value as this one, in the same way that this one here will be the same value as that one there. So we're getting a good few angles already before we even begin. Once again, we have another parallelogram down here. That makes that 120, which will make this one 60. Once again, the two interior angles have to give you 180. That'll give this one an angle of 60. And then we know that the angle N will have to be 300 because a full circle is 360. Write down what each one is, alright? So look, N is a reflex angle because it's bigger than 180 degrees. So that means that's angle N. Acute angle will be angle, I think I wrote all over it already, angle K, because it's smaller than 90 degrees. An obtuse angle is anything bigger than 90, but then smaller than 180. So that will mean that will be the angle M. Okay, so that's where all three of them angles are. Okay. Work out each of the angles K, M, and N. Remember, the two triangles are equal. Well, pretty much already done that already for us. So K is 60. Angle M is 120. And then angle N is 300. Already done. The two equilateral triangles are not the same size as each other. Siobhan says the two triangles are similar, but they are not congruent. Give two reasons why the triangles are similar. Well, the difference between similar and congruent is the following. If I have this man here, and I was to clone him, a clone is the same thing in every regard. It's the same size, same shape. All right, so these are similar and they're congruent because they're exactly the same size. However, when I make the clone bigger, it's still the same shape. So the clone, the larger clone is still similar to the original image, but they're not congruent because they're not identical in size. Okay, so the two reasons why the triangles are similar and they're similar, but they're not the same, is both triangles are equilateral, so they must have the same angles. Okay, both triangles are equilateral. Okay, so they must have the same shape. Okay, and then second reason is congruent triangles are the same size. Triangles must be the same size. Okay, so hopefully that explains that. Okay, moving on. Give a reason why the two triangles are not congruent. Alright, we just did that a second ago. The two triangles aren't congruent. So that's the answer to part 1. And then congruent triangles must be the same size, and that's the answer to part 2 because they're not allowed to be the same size as you. Okay, so that's all good there. Done. A small triangle in the diagram has sides of length 4 centimeters. The big triangle has sides of length 8 centimeters. Use this information to construct a diagram in the space below. Show clearly any to construct a diagram in the space below. Okay guys, so essentially I have to basically make a diagram of this. So I'm going to start off with the need to get my own ruler here. Okay, I'm going to start off with the 4 centimeter smaller triangle. Okay, and I'm going to make my ruler slightly smaller because I don't want to be running out of space here. I'm going to start off in the top right. Now what we're going to do first and foremost is I'm going to basically make a 4 centimeter line. I'm essentially starting here and here, if you will. The small sides are 4, the large sides are 8. I'm going to slowly construct my way around. So I'm going to need a protractor, or sorry, a compass. Okay, what I'm going to do next with the compass is I'm going to get it at 4 centimeters, like so. Okay, actually better make sure that's exactly 4. Don't forgive me here. Okay, just get myself a bit more to the 4. Precision is everything. Okay, there we go. Now, once you have this at 4 centimeters, very easy. You tilt upwards like so. Create yourself a little arc, like so. Then move to the other side of the line you created in the first place. Once again, bring your line up. Now, where these 2 points hit each other, it makes the 2 other lengths the same length. Okay, so I need all of these the same color. So if I go here to here using a ruler, I've now created a equilateral triangle of 4 centimeters long. Okay, the next thing I'm going to do from that is I'm going to go across 8 centimeters to the basically going to go across 8 centimeters like so. Okay, I'm going to make the next equilateral triangle the one that's the 8 centimeters long. So once again, just going to get my my protractor like so, and then go down, take it to 8, like so, and then go above and below. So I'm going to make a nice big arc like this. Then I'm going to turn it around. I'm going to go to the other mark on the 8, and then swing that down below to once again construct a second equilateral triangle. Once again, all of mark 8. Okay, so there's 2 more construction lines used. And once again, you're just going to get your ruler and link the 2 of them together like so. Okay, so there's my two equilateral triangles so far. All good. The next thing I'm going to do is, if you look at this, you basically have 2 parallel lines. This line here has to be parallel to this line here. Okay, so what I'm going to do is I'm going to get myself a compass and a straight edge, or sorry, two straight edges. So we're going to go for this triangle here, like so. And what we can basically do is, if I match, try and think of this now. I'm always trying to think of this one. Okay. So what we can do here is, we know that's a length of 4. Okay, so we could try it this way as well. We could put this beside each other like so. And when they come down, it's only able to move. You're pushing it against the straight edge, and you're going all the way down. Okay, like so. And see the way you're roughly at the 4 mark. Okay, now we're going to try and I'm trying to think of another way of doing this one actually. Another way of doing it is to line up your triangle along that edge. Okay, and then what you can do then is you can line up your ruler parallel to this. If I can find the angle on my ruler, that is very difficult for me at times. Okay, So we line up my ruler as best I can with this. Okay, you see they're interlocking, and then what can happen here is I can slide down my slanty edge. Oh, keep it in position. I can slide down my slanty edge until it's down here. Okay, and what you can do is you just like mark off an initial mark. You can do initial blue line, and once you have that initial blue line done, all you have to do is go in and make sure that it's 4 centimeters long. So see I'm at 7 there, I'm going to go 7 to 3. Okay, no worries there. So I'm going to go mark off from 7 to 3 like so. There's my one line done at the parallelogram. Then I can just get my ruler and link the old parallelogram to the new one, and that's that line done. I'm going to do the same trick up here, where we link, what I can do here is, once again, I can get my slant angle like so, perfectly tuned to this one here. Okay, then I can grab my ruler like so, and then tilt my ruler so that it's along the back edge of the bottom edge of the triangle, or the set square I believe it's called. I can slide this again. You can slide one of them on top of the other one, and then when that happens I get to the very edge here, and then once again you can see that I'm able to just do a line that's parallel to that. Okay, and then I can measure it properly with the ruler, or in fact I can just measure properly with the ruler. Just delete that off there, go in with the ruler now and make sure it's 4 centimeters that it's meant to be. It's pretty close there actually, just a bit more, and there we go. Now we have the other one done, and then long and behold, there is my diagram, pitch perfect as it was before. Okay, now we're on to question 7. The triangle has one side of length 10 and another side of length x. The perimeter of this triangle is 26 centimeters in length. Fill in the third side in each case in the table. So perimeter means the 3 sides add together, so 4 plus 10, the other side is going to have to be 12, because 12 plus 10 plus 4 is 26. And then the length of this side is going to be 19 plus 7. 19 plus 7 has to make that equal to 26. So we got the length of the third sides in both cases. Okay? So that's easy enough. Now we'll go on to the next question after that. Alright, already did that. Find the 3 values of x that make the triangle an isosceles triangle. Alrighty. Length third side. So an isosceles triangle. Well, if the perimeter still has to be 26, what I could do is make a value of x that makes the triangle an isosceles triangle. Okay, so the triangle has to be isosceles. Well, I suppose this one could be 10 plus 10 plus 4, but the other side won't be 10, 10, 4. Okay, I'll have another think about this one. Okay, so in the last question, what we found out was that this is, so we found out that the third length was 12 in the first triangle, and the third length was 7 in the second triangle. Okay, and in order to make these isosceles, what we'd have to do is we have to change the x value. Okay, so to change the x value, if we change x into 10, that would make that an isosceles triangle. Okay, now its perimeter would no longer be 26, but an answer 10 will work nicely. Okay, and then what we could say on the other one is, so I want 3 values of x. So that means what? Okay guys, so but looking at these questions here, I think what it's basically saying is that in part 1 it basically says that it has to be triangle of 10 or side length of x, the perimeter triangles 26 centimeters length, fill in length third side, right? So we did that successfully part A. Then it says find the 3 values of A that make the triangle an isosceles triangle. Okay, so find the values of x that make it an isosceles triangle. So this means that only 10 is fixed and the other lengths can be anything you want them to be. Okay, so if we go back here, if I set this equal to 8 and that side is 8, so then we get 8 as a possible value, 8. Okay, we could also try for 10, 10, and then just make the other side 6. 10 would also work. Okay, then we go to the last one. Okay, I think it's just 8 and 6 to be honest, because it has to be 10 and the perimeter has to be 10 and the perimeter has to be 26. So yeah, I just got 10 and 8 there to be honest. 10, 10, 6 for the first one. And then the other one is 8, 8, 10. Okay, it ought to be 26. So you need to be 10 or 8. The other, it won't be a perimeter of 26 if we use any other value. So I'm only getting 10 and 8 here, guys. Okay. And that's maintaining the perimeter of 26. Anything else, I have to change the 10 value in terminology. I'm not allowed to do that according to the language of the question. Okay, so I'm going to leave that one alone now at this rate. Now, the graph below shows the area of a triangle for all values of x between 3 and 13. The point A is marked. A is the point on the graph with x equals 4, represents the diagram in A. Use the point on A to estimate the area of diagram A. So if we go back to diagram A, we said that's what's it, 4, 10, and 12. Okay? 4, 10, and 12. Okay? And what we have here, guys, is the area of this triangle, okay, when x equals 4. So in the area when x equals 4, we go across and go straight across like so. And it's somewhere between 17 and 18. So let's go, I don't know, 17. Sorry, no, it's in between 18 and 19, excuse me. So that's 16, 17, 18, somewhere between 18 and 19. So let's call it 18.5-ish. Okay, anywhere between 18 and 19. Okay, now we're on the next question then. Plot a point B on the graph to represent the triangle in diagram B. Well, in diagram B, we said x equals 9. Okay, so we're going to have to do x equals 9 here, guys. So we go to this diagram here, like so. And so we just keep my old point here. So x equals 9 will be located up here. Then we draw a line going straight across. You see it's just above the 30 mark, in between 30 and 31. So I suppose what we could say for this one is it's the point 9 and 30.5. And wants me to call it point B. So that's the point B there. Okay. The graph is symmetrical. Draw the axis of symmetry above. Write down the equation of the axis of symmetry. Well, an axis of symmetry is basically if you just cut it straight down the middle. into two perfect halves, so both halves could fold in on each other. So this means the axis of symmetry is the line x equals 8, a vertical line where all the values are always x equals 8. Okay. When x equals 5, the triangle has sides 10, 5, and 11. Show that this is not a right angled triangle. Well, if it's a right angled triangle, Pythagoras' theorem would work, where the longest side squared equals the other sides added together, squared and added together. So 11 squared should equal 10 squared plus 5 squared if it was right angled. But it's not right angled because 121 does not equal 125. So we can say not right angled. Okay. Nextly, the diagram below shows the triangle with the biggest area. Work out this triangle, give your answer in the form 5 over root n. Now it's an isosceles triangle, and in isosceles triangles, it can go straight down. So one side will be 5 and the other side will be 5. I'm going to use Pythagoras' theorem to find out the length of the blue line, because we want to use a half base times height. We know that the base is 10. But we don't know what the height is. So to find the height, what we're going to do is the following. We're going to do 8 squared, 8, 5, and h. So 8 squared equals 5 squared plus h squared. 64 equals 25 plus h squared. 64 take away 25, root 39. So h squared equals 39. And h equals the square root of 39. Okay, so it's going to be a half base times height. So it's going to be a half 10 times root 39. And this means a half 10 is 5, so it's going to be 5 root 39 is our answer. N, element n means it's just a natural number. 39 is a natural number, so this is our answer. N equals 39. Okay, let's move on. Oh, thank God. All right. The net below is folded to make a fair die. So basically, when you fold this, it turns into a dice. Okay, like so. And on the front, for argument's sake, say 3 is the base number, so 3 is on the bottom, invisible. 4 will be in the front. 1 will be at the side. 7 will be this side. 5 will be at the back. And 8 will be on the top, and 3 will be on the bottom. What number will be opposite 7 on the dice? Well, 7 is opposite 1. Okay, so 7 will be opposite the 1. Okay, next question. The dice is rolled once. Find the probability that the number is greater than 6. Well, to be greater than 6, you either need to be 7 or 8. That's a 2 out of 6 chance, which is a 1 in 3 chance. Okay, next question. So I've done A, I've done B. Okay, now I'm doing C. The dice is rolled 60 times. How many times would you expect an odd number to be rolled? Well, the odd numbers are 1, 3, 5, and 7. That's 2/3 of the time. So 2/3 of the time, or 4 out of 6% out of the time, you're expecting a odd number. So multiply 60, the number of trials, by the probability of getting an odd number, and we realize that it should be 40 times, as in 40 times out of 60, also 2/3. So 40 is the answer we're looking for there, guys. Okay, now we're on to part D. The following 3 terms are used when discussing experiments and probability. Outcome, sample space, and event. The set of all possible outcomes of an experiment, sample space. One possible result of an experiment, that is an outcome. A subset of the sample space, a collection of one or more outcomes, an event. Okay, happy days. Now, thank God, 9. Jared flips a coin 3 times. Each time he gets heads or tails. Okay, and what we're going to do is complete the table below, write heads or tails in the diagram, fill in the 5 missing outcomes, write down the number of heads in each of the outcomes. Okay, so here's our diagram here. So when you flip a coin 3 times, you have certain outcomes, okay? So the first outcome of the first flip is a head or a tail. Then that in turn, when you flip it a second time, you have a head or a tail. Then third time, head or tail. So you need to track it down. Head, head, head is head, head, head. Then you have head, head, tail, which only has 2 heads. Then you have head, tail, head, which has 2. Then you have head, tail, tail, which only has 1 head. Then you have tail, head, head, which only has 2 heads. Then you have tail, head, tail, which has 1. Then you have tail, tail, head, 2 tails followed by a head, which has 1 head. And then finally tail, 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 3 tails in a row, which has 0 heads. Done. Each outcome is equally unlikely. Fill in the following to show a probability if Jer gets an even number of heads. The probability that Jer gets this number of heads. So there's 8 results. 1, 2, 3, 4, 5, 6, 7, 8. Okay, great. Now out of this 8 results, there's only 1 0. So that makes that 1 out of 8. The next one is 1 head. 1, 2, 3. There's 3 of them that have 1 head, so 3 out of 8. Then there's 3 of them that have 2 heads. 1, 2, 3. 3 heads. And then finally 3 heads and top. Sorry, 2 heads is 3 out of 8, and 3 heads will be 1 out of 8. She flips the coins 8 times. Each time she gets heads or tails. Write down the number of outcomes that have no heads. No heads. She flips it 8 times. So if she flips it 8 times, sure there's only one outcome where she hasn't got a head. So it's going to be a tail, 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 tail. Tails all the way through, which is just one outcome. Every other outcome will at least have 1 head in it. Work out the number of outcomes that have exactly 1 head. Okay. Work out the number of outcomes that have exactly 1 head. Okay, so let's try this out. Tail, 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 head. And then just keep moving the head all the way over. So it's going to be tail, 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 head, tail. Keep moving the head across. Tail, 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 head, tail, tail. Look, we're going to have to do this all the way until it's at the very end where it's going to be head, tail, 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 tail. That is exactly 8 outcomes. Eight outcomes have 1 head. Okay. Work out the total number of outcomes when the coin is flipped 8 times. Well, when the coin is flipped 8 times, what happens is each time, so that's 1 box, 2 box, 3 box, 4 box, 5 box, 6 box, 7 box, 8 boxes. There's 2 outcomes for the first one, 2 outcomes for the second one, 2 outcomes for the third one. There's 2 outcomes each time you flip. And what you got to do is you got to end up multiplying these by each other. So you got to multiply 2 by itself 8 times to find the total amount of outcomes. Same thing as 2 to the power of 8, which is 256 different outcomes. Okay. Work out the circumference of a circle with diameter 8. So circumference is L equals 2 pi r. Okay. And then what the radius is going to be is 4. So L equals 2 pi multiplied by 4. Put it all into the calculator. And you're going to get 28 pi, which should round off to 25.1 centimeters. Happy days. The rubber track of a toy digger goes around with 4 circular wheels of diameter 8 as shown. Calculate the length of the rubber track that goes around the four wheels. Give your answer correct to one decimal place. Alright, so look at this. These are two straight lines here, okay? So we're just going to take the straight lines first. Okay, so let's get, just going to color these in green. So I'm just going to get the two green lines first. Okay, so that's going to be 4, that's 8, that's another 8, and that's a 4. So the green lines are going to be 20 centimeters each. Okay, now we've already got the circumference of this circle. See this one here, if I do the red line, that's half a circumference of a circle, and that's the other side of the circumference. So I think it's going to be 25.1, which is the two red areas combined to make the single circumference of the circle, plus the two greens, which would be plus 20 plus 20. I believe it's going to be 65.1. Unless I missed something. Oh, sorry, 24, not 20, 24. My fault. Don't know that these days. These are about 24 as it turns out. So 24 plus 24 plus 25.1. And what we should get there is 73.1 centimeters. Okay, happy days. Move on. Every time the wheel turns fully, the digger travels a distance equal to one of the wheel's circumference. Work out how many times each wheel will turn fully when the digger travels a distance equal to the length of its rubber track. So the rubber track we all said earlier was 73.1 centimeters. And we're going to have to divide that by basically the circumference of the wheels. Just one wheel, that is 25.1. So how many times will that go in? Well, that'll go in 2.9 times, which unfortunately is only 2 full turns because we didn't quite complete the third turn. Okay, so when it does the length of the track, it only goes 2 full turns. Okay. Next one, 11. Diagram below, two sides have a length s where 0 is less than s less than 6. S can be a decimal or a fraction. All angles are 90 degrees or 270 degrees. Find a formula in algebra for the area of this shape. Well, area of this shape, let's find out. What could we do? Suppose we have two different, suppose we could yeah, I could do it this way, where I pretend it's the area of the large rectangle, which we all know is 10 by 60. Oh, sorry, 10 by 6, I mean. 10 by 6 to get your 60. And then what I'm going to do is going to take away this area here, which is minus your s by s, which is your s squared. So it could be 60 take away s squared. Okay, that's the easiest way to do this one. Or there's a second way of doing it, where you split it up like this. Okay, and if you split it up like that. Oh yeah, this is a bit more difficult. So here to here is s. So red to red is s. And then, yeah, let's not do it any other way. That's the easiest way to do it, guys. We'll just keep it like that. Right? It's the easiest way to do it. Now, show that or explain why the perimeter of this shape is always 32, no matter what the value of s. Okay. Let's add everything together and see what happens. Maybe the s's disappear when we do the perimeter. We'll find out. Okay. So the length of here to here If here to here is 6, and for argument's sake, see these 2 points here? Actually, we'll just do it like this. See this red shape here? If I bring that over this side, that's S, which makes the bottom part from here to here 6 minus S. So this point here has to be 6 minus S. Okay? In the same way, when we look horizontally, here to here is 10, but here to here is S, because S is the length from here to here. Okay, so if we go down this way, what we can say is that if that length is S, this length from here to here must be 10 minus S, and that in turn must mean that's 10 minus S. Okay, now what we're going to do is we're going to find the perimeter by adding all the sides together. Okay, so I'm going to copy and paste this. Onto current page. It's a bit on the large side, so then we're going to chop it down to size, like so. Going to cut it. And then we're going to move it over. Where's the paste button? So just undo my last one. Didn't quite copy it. Paste it. So here it is here. So I need to try and get this, see what happens there. So I'm going to add these together. I'm going to start here and work my way around. So it's going to be 6 minus S plus an S plus S plus 10 minus S plus 6 plus 10. And what you can see is the S's will cancel. That cancels with that one cancels with that one. And you're going to be left with 16 plus 16 equals 32. Perimeter does not depend on S. Okay, sorted. Next one, prove that the exterior angle of a triangle is equal to the sum of the interior to opposite angles. Okay, so look, that's a proof. I won't do that. I'll move on. Question 13. Use trigonometry to work out the value of x in the diagrams below. Give your answer correct to 2 decimal places. Well, we have opposite and we have adjacent. And if we use SOHCAHTOA, we have tan. So tan 20 equals opposite over adjacent. So this cross multiply up the x, so you get x tan 20 equals 6. Tan 20 is multiply on the right, which means it's divide. So multiply on the left, which means it's divide on the right. So 6 divided by tan 20. And we get 16.48. Okay, so that's 16.48. Happy days. Now, next part. B. A different right angle triangle is shown on the right. It has one length A, B, and C. One of the angles is Y. In this triangle, A plus B is bigger than C. Use this to prove that cos Y is plus sin Y is bigger than 1. Okay, let me see. A plus B is bigger than C. Okay, so let's find out what cos Y is. Cos Y is adjacent over hypotenuse. Sin Y is also adjacent over hypotenuse. Hypotenuse is C, opposite is B, adjacent is A. So what we're going to get here is A over C. Sine y is going to be B over C. Okay. So let me see what we can do this here. A plus B over C. So we know that A plus B is greater than C. Now what happens if we divide both sides by C? See the way we want A over C and B over C? Divide both sides by C. And now you get A over C plus B over C is greater than 1. Essentially, cos y plus sine y always has to be bigger than 1. And that's it proven there. Okay. Question 14. Cylinder has a radius of r and a height of 10, so 10 and a radius of r. The cylinder is melted down and made into a cone. This means their volumes are the same because it's the same amount of material on both of them. Well, it should be the same, but 10% of the volume is lost during this process. So it's actually, the cone is 90% of the cylinder. Work out the percentage increase in height of the cylinder when it's made into a cone. Oof, very tough question. So here's what we're going to try first. Increase in height. So it's going to be difference in height divided by original height, which is 10, and then you're going to multiply that by 100. For argument's sake, if the cone came out as 15 centimeters, what you could say is it's 15, so it's the difference in height, so 15 take away 10 is 5, be 5 over 10 multiplied by 100. This would compute to a 50% increase in height. So the problem is we don't really know the height of the cone at the moment, so we're not going to even bother with that at the moment. Okay, so here's what we're going to do instead. Let's get the volume of the cylinder, because we know that the volume of the cone is 90% of that cylinder. So volume of cylinder is pi r squared h, which is just going to be pi r squared times 10, which is 10 pi r squared. Now, what's going to happen next is we lose 10%. When you lose 2%, you only retain 90%. 90% is the same thing as multiplying it by 9 over 10. When you multiply it by 9 over 10, you're going to get 9 pi r squared. This 9 pi r squared is equal to the volume of the cone. Now the cone also has a radius of r, but remember the volume of a cone is 1/3 pi r squared h. So it's going to be 1/3 pi r squared new value of h. Now the height of the cone, the pi r squareds on both sides will cancel because they're the same thing. So we're going to get 1/3 h equals 9. Multiply the h by 3. The new height is 27. Okay, so that is 27 for the new height, which is a bit of an insane increase if I'm being honest. Okay, so what did we say earlier about the formula we're going to use? We said the increase is 17 divided by the original value, which is 10, multiplied by 100, which will get you a 170% increase. Okay, so I think this is question 6 upwards now.